All right, welcome back to statistics, and we're going to continue our discussion of t-tests. So we can call this part 3 of our series on t-tests. And today I want to talk about a matched pairs t-test. And the typical example of this is we do a matched pair, we do the same experimental subjects before and after. There are other cases, ways of creating a matched pair, but this would be the typical one. For example, if we had the same students, if we want to look at how well some SAT coaching does, we take the same students and we look at those students before and after the coaching. So we have the student, we have their score on the verbal SAT before they're coached, and then they get coached and they take the SAT again, and we look at what happens after they're coached. So student A, let's say, gets a 540 the first time and a 560 the second time. Student B gets a 590 the first time and a 570 the second time. Student C gets a 600 both times. And so on down the line. Okay, and let's say we did this for, and what we do is we focus on the difference between them. So the difference in this case, let's take after minus before. So that's plus 20, this is minus 20, this is 0, and then we get a whole bunch of other differences, and then we average them. So let's say that the average difference for, let's say we have 15 students, the average difference, which we'll call x bar, is 9.4, and that the standard deviation, when we take the standard deviation of this column of numbers, is 6.2. And the question is the difference, true population difference, greater than 0? That is, did we gain from the coaching? And for that, we would just do a one sample t-test. So one sample t-test, or just a plain t-test, with the mu naught is 0. That's very often the null hypothesis when you're doing matched pairs, is there's no difference. And then we put in our sample size of 15, our x bar and our s. We calculate a t value and a p value and see what happens. So that is how so a matched pair is just winds up just being a regular t-test. Nothing exciting. We just use the plain t-test in the calculator. What's the difference between matched pair and two sample? Well, let me give an example. In this case, suppose we were a little suspicious that suppose we decide that just taking the SAT for a second time gives you tends to give you a higher score. Well, in that case, if we're just looking at this before and after, we don't know whether the before and after difference comes from coaching or whether it comes from just taking it a second time. So in that case, we might take, I don't know if this makes sense, but two different matched pairs. We could take a control group. Let's say we had a control group of 20 students, and we do their before, and then we have them take the test twice, and then we do a quote before and after. and after means that nothing really happened. They just took the test a second time. And then we compare that to the experimental group. Let's say of 15 students who get coached before the second time. So coached on the for the second test, before they take the second test, and see whether the coaching or the the SAT preparation helps them. So that would be when we compare the control group and the experimental, now we're doing a two-sample test of some sort. Not sure how I would calculate the sample statistics, but in theory, perhaps we could do something with that. Okay, so how do we tell the difference between matched pair and two-sample? The main difference is that with a matched pair, the same n is absolutely necessary. It simply would not make any sense to be talking about before and after where we have a different number before from the number after. So there's really a single n. There's just one n, which is why we use the one sample even though we're doing a before and after. We use a one sample t method. So it could either be a t-test or a t-interval. Two-sample, if we have the same number in both groups, it's a coincidence. But there's no logical requirement for there to be the same n. So it's not logically required. So if you're trying to decide whether to use a two-sample t-test or a one-sample, thinking of it in terms of matched pair, try to decide whether the sample size in your two groups necessarily is the same as it would be the case in a before and after, or whether it would only be the same because of you just happen to have the same number in two groups, but in principle you could have different numbers. So if we were comparing one group of students that was coached and one group that was not coached, and they were different students, then the n would not necessarily have to be the same. They could be the same, but they don't have to be. With matched pair, the n has to be. I think that's the main difference, and I think I'll call it there.